Hello, everyone. My name is Andy Hopper, and I'm a Senior Solutions Architect at Amazon Web Services. A frequent use case for customers running Elastic Compute Cloud or EC2 instances is to have a way to automatically install applications on these instances. For example, you may have a CI/CD pipeline that builds your code, and you'd like to have the latest revision of the application deployed after the build completes. However, what if this application is running in production and you can't afford to have any downtime even while you're updating the application? In this video, we're going to explore how you can use one of AWS's DevOps services named CodeDeploy, and we'll look at one of the deployment types that can enable this, and it's called blue-green deployments. So what is a blue-green deployment? For a lot of applications, the way you update the deployed version is to uninstall the previous version and then install the new version. Now, CodeDeploy has ways to allow you to perform the update on a fraction of your boxes at any given time so you don't have any downtime, but sometimes you'd like to ensure that everything gets updated at once, but still without any downtime. This is where blue-green comes in. Rather than update the boxes that are currently running your application, which we'll call the green group, we'll instead create a separate set of boxes, which we'll call the blue group, and install the application version on them. Once we're satisfied the application is running properly in these boxes, we'll make them the green group. Now, I do have to make sure my application is written to handle this, but if I do it correctly, my users might never know that anything changed, even while they're using the application. For those of you who aren't familiar with CodeDeploy, it's a way for you to have software automatically installed on EC2 instances, Elastic Container Service or ECS services, or even AWS Lambda. For the purposes of this video, we're going to focus on a Windows use case running on EC2. However, if you're interested in performing similar steps on other OSs or platforms, you can learn more from the AWS documentation on CodeDeploy. So let's get started. What I have open here in Visual Studio is an ASP.NET Core MVC web application. Now, I'd like to point out that while this particular application is using the .NET Core runtime, everything I'll be describing in this video applies to .NET Framework applications as well. You're just going to be using a different runtime for your application. By the way, the source for this application is publicly available in GitHub, so if you want to peek at the code for this, as well as some other videos I'll be recording on deploying .NET applications, you can download it and try it out in your own environment. Okay, back to our application. I'd like this application to be able to launch automatically on boot and stay running. This is an ideal use case for a Windows service, so I've added the NuGet package that supports running a .NET Core application as a Windows service. So I've got my application, I've got it set up to run on boot, so now I just need to figure out how I'm going to get this to automatically install on my instances. Before we use CodeDeploy in the blue-green deployment type, there are a few things we need to make sure we have in place. First, we'll need to ensure that the EC2 instances we're using have the CodeDeploy agent installed on them. And in addition, we'll have to ensure that that agent will have permission to talk to CodeDeploy through the CodeDeploy APIs. To do this, we'll ensure that we have an EC2 instance profile attached that includes the necessary permissions to work with CodeDeploy. Luckily, Amazon has already provided what's called a managed policy called Amazon EC2 role for AWS CodeDeploy that we can use for assigning these permissions. We'll also need to make sure that the EC2 instances my applications are running on have the ability to access the CodeDeploy and S3 public endpoints. To do this, we'll need to ensure that the VPC my EC2 instances are on have access to the internet through an internet gateway. If I'm launching my application on EC2 instances in private subnets, we'll need to make sure that those private subnets have access to a NAT or a NAT gateway so that they can have access to the outside world. Finally, we'll need a set of EC2 instances that we'll use for deploying any new revisions we publish. To do this, we can either manually provision a set of EC2 instances, or we can point CodeDeploy at an auto-scaling group that already includes the configuration needed for those new EC2 instances. We're going to use the auto-scaling group option for this example. So let's go ahead and get things set up. First, I'll go ahead and create the EC2 profile. I'll go to the Identity and Access Management console. I'll go to Roles, and I'm going to create a role. In this case, to make an EC2 profile, we'll pick EC2 for the use case. And now it's time for me to attach policies. Now, as I mentioned, we have a managed policy for CodeDeploy, and so I'm going to go ahead and check the Amazon EC2 role for AWS CodeDeploy. I'll skip past the tags, and I'll give it a name, Core Demo, and I'll leave the description as the default. Okay, great. I've got my EC2 profile, and now it's time for me to create an auto-scaling group. Okay, we have our EC2 instance profile. Now it's time for us to go ahead and create a load balancer to serve up traffic from our application. So I'll navigate to EC2, and I'll scroll down to load balancers, and let's create a new load balancer. In this case, I'll go ahead and use an application load balancer to serve up my traffic. So it'll want a name, ASP.NET Core Demo. It'll be an internet-facing load balancer, and it'll serve traffic up on port 80. Next, it wants to know what availability zones and subnets it's going to be running the ALB out of. And so I'm going to go ahead and check the CodeDeploy demo VPC that I've already created. And I will have it serve traffic in the public subnet in these two availability zones. In this case, I'm not going to use the AWS Global Accelerator, so I'll go ahead and skip to security settings. And I'm not setting up an SSL cert at this time, so I'll go ahead and skip that. Were you setting this up, you would configure SSL here. Next is it's time to configure the security groups. In the VPC that I'm going to run my application in, I've defined two security groups. So I've got a load balancer security group, which allows access on port 80 to 0.0.0.0. And then I have the CodeDeploy HTTP security group that we'll use in our launch configuration. This security group only allows access on port 80 to this load balancer security group. That way, I can run these applications in a private subnet, and there will be no internet access to these boxes directly. It has to go through the load balancer. Next, we'll configure the routing. I'm going to go ahead and define a new target group. And so variations on a theme here, I'm going to name it ASP.NET Core Demo. It's going to be of instances, and I'm going to go ahead and have it serve traffic to port 80, and the health check will just be the root of the application. In this case, I'm not going to register any targets at this point. We're going to let the auto scaling group manage that part. So next, we'll click Review. It just shows us all the choices that we've made at this point, and we'll go ahead and click Create. Awesome. Now we have our load balancer. All right, so for an auto scaling group to be able to create EC2 instances automatically, first I have to give it something called a launch configuration. So I'll go ahead and click on EC2 to go to the EC2 dashboard. I'll scroll down and I'll click on Launch Configurations. And then I'll click on Create Launch Configuration. So it's going to ask me for a name, so I'll call it ASP.NET Core Demo. And then it needs an AMI ID. Now, in my case, I've already looked up the AMI for Windows Server Core, so I'll just go ahead and paste that, Windows Server Full, and I'll paste that in here. Next, it'll ask me a few additional details. So I'm going to go ahead and choose an instance type. This is going to be web application, so I'll go ahead and make this a C5 large. I'll choose that. And then next, it's going to ask me for an instance profile. In my case, since I want to be able to interact with CodeDeploy, I'm going to go ahead and choose that ASP.NET Core Demo instance profile we created earlier. Next, it's going to ask us some advanced details. And one thing that I need to do, as I mentioned earlier in our prerequisites, is that I need to have the CodeDeploy agent automatically installed on the machine. So what I'm going to do here is I'm going to use a user data script that I've already written. What this will do is it downloads and installs the CodeDeploy agent onto the machine. And all it's really doing here is I'm creating a temporary path. I download the CodeDeploy agent from the location that we have published in the CodeDeploy documentation. And then all I'm doing is I'm actually running the CodeDeploy agent installer on the machine. And I'm indicating that I'd like for the user data to wait until that CodeDeploy agent has completed successfully. All right. As far as EBS volume size is concerned, I'll go ahead and accept the default of 30, but it is going to ask me what security groups that I'd like to use. Now, as I mentioned earlier, we've got our CodeDeploy HTTP security group, so that's the one I'm going to use for the instances. If you recall, what this security group is going to do is allow access from our load balancer to call port 80 on any instances in the security group. And it's just showing a warning message. I haven't opened up 3389, which is fine. I'm not going to launch these with a key pair. As a matter of fact, right here, I'm going to indicate that no, I am not going to use a key pair for these instances. CodeDeploy is going to be the only thing that will be doing anything on these boxes. So let's go ahead and create our launch configuration. All right, we have our launch configuration. Now it's time for us to create our auto scaling group. So let's go ahead and create our auto scaling group. To do that, we'll navigate to the EC2 console. We'll scroll down to auto scaling groups, and then we'll click on the create an auto scaling group button. And you guessed it, we're going to name it ASP.NET Core Demo. And then you'll notice in this case it's asking us to pick a launch template, but we can switch to launch configuration. Since I've defined mine as a launch config, I'll go ahead and switch to that. And I'll pick our ASP.NET Core Demo launch configuration. And you'll notice it's got the AMI ID we picked, it's got the instance type we chose, and you'll also notice that it doesn't have the a key pair associated with it. So let's click Next here. Then it's going to ask us what VPC we're going to launch these instances into. I'm going to choose the CodeDeploy demo VPC that I've already created. And I'd like these instances to go into the private subnets. I'll let the load balancer live in the public subnet and be accessible to the outside world. Next, I'll enable load balancing. And then it's going to ask me, what target group my load balancer is using. I'm going to select the ASP.NET Core Demo target group that we created earlier. And then I'll click Next. And then it's asking me some information about the size and number of instances I'd like. Let's go ahead and we'll set everything to 2 here. So I'll say I'd like to have a minimum of 2 instances just to show how CodeDeploy works. And I won't bother setting up any scaling policies or whatnot. I'll just leave it at 2. Now, this is all where you could optionally configure any kind of notifications if you want to receive SMS or email notifications when auto scaling takes effect. I'm going to go ahead and skip this here. We'll move to next. And then finally, we have the chance to add tags to our instances. I'm going to go ahead and add a name tag to our EC2 instances, and we'll call this CodeDeploy Demo. And we'll click Next here. And finally, we just review all the choices that we've made up to this point. And I will go ahead and click on Create Auto Scaling Group. All right, now at this point, what's happening is the auto scaling group is creating the EC2 instances that it needs to actually create. Rather than make you folks wait for this process to complete, I'm going to use the magic of video editing, and I will just see you on the other side after our EC2 instances have been created. All right, it's time to create our CodeDeploy application. So to do that, we'll click on CodeDeploy to navigate to the CodeDeploy dashboard, and we'll click on Applications. So let's create one. And I think you know what name I'm going to use for my application by this point. And then we get to choose the platform we're going to use for our application. Now, this is a cool feature of CodeDeploy. I have the ability to deploy to EC2 instances or my on-premises machines, but it also natively supports the ability to deploy to Amazon Elastic Container Service, ECS, or to AWS Lambda. But in this case, we're going to stick with the Windows EC2 instances that we've already had our auto scaling group create. So we'll go ahead and click Create Application. And then next, it's going to ask us to create a deployment group. So let's go ahead and do that. So next, we'll want a deployment group name, and I think we know what I'm going to use. And then next, it's going to ask us for a service role. And this is actually, I forgot to mention this in the prerequisites. So let's go ahead and take care of this. In order for CodeDeploy to work, it's got to have a service role that grants it access to invoke the CodeDeploy APIs. So let's go ahead and we'll navigate to Identity and Access Management. And we'll create a service role for CodeDeploy. So we'll click on Roles. We'll create a new role. And instead of EC2 like we did for the instance profile, we'll scroll down and we'll go to CodeDeploy. And then it's going to give us what our options are here. Now, in this case, I'll just choose the vanilla CodeDeploy. You'll notice that there are 2 other service roles, one for ECS and one for Lambda. In this case, I'm deploying to EC2, so I'll just choose the original. Next, it'll prompt us for permissions, and it'll already have the AWS CodeDeploy managed policy attached to it because it is a CodeDeploy role. I'm going to skip the tags. There's nothing I want to add here. But then finally, I'll have to give it a role name. So we'll call this CodeDeploy service role. And I'll leave the description as it is. So let's go ahead and click on Create Role. And great, now we have our new service role defined. So let's go back to the CodeDeploy console. And what I'll need to do is just kind of recycle the page here so it'll refresh. So I'll click Create Deployment Group again. And now I'll get to go ahead and choose our ASP.NET Core Demo for the deployment group. But now when we choose service role, our brand shiny new CodeDeploy service role is available to us. Next, we're going to be prompted for the deployment type. Now, in this case, we're interested in using the blue-green deployment type rather than the in place. So let's go ahead and select blue-green. Then it's going to ask me what set of EC2 instances am I going to deploy the new revisions to? As I mentioned earlier, you can either use manually provisioned EC2 instances, or you can use an auto-scaling group. In this case, we're going to go ahead and use that auto-scaling group that we defined, and we'll choose the only one that's available to us, ASP.NET Core Demo. Next, it'll ask us how we'd like to handle traffic rerouting. Since we have a load balancer attached to this, I can either decide when I'm ready to have the traffic go to the new instances, or I can go ahead and let CodeDeploy automatically reroute that traffic. I'll go ahead and use the default and let CodeDeploy just automatically start sending traffic to those new instances after everything's been properly installed. I'll then get prompted for how I'd like to handle termination of the EC2 instances that were in the original green group. What this allows me to do is if I need to, I can repoint my traffic back to the original green instances just in case something went wrong with the deployment. I'll go ahead and have it terminate the original EC2 instances just because I don't want to keep them around after I'm done with my deployment. Next, it's going to ask me what configuration I'd want to use. And since I'm using blue-green, I'm going to go ahead and choose all at once. You can also decide if you want to deploy it to one instance at a time or half at a time, or you can even create a custom deployment configuration for your own custom percentages. Since this is blue-green, I'll just go ahead and have it deploy to all the EC2 instances in the blue group all at once. Next, it's asking how I'd like to configure load balancing for the traffic going to this application. We're going to go ahead and choose the target group that I already have in place for the ASP.NET Core Demo Load Balancer. And we're ready to go. Let's go ahead and click Create Deployment Group. Okay, so we have our deployment group. We have our CodeDeploy application. Now it's time to deploy a new revision of our application to our blue-green environment. All right, so let's create our application revision for deployment. So we're back in our ASP.NET application. And if you look here, I've taken the liberty of already building the necessary infrastructure to deploy our application in the interest of time. Now, what CodeDeploy expects is at the root of the zip file, which is your application revision, there will be a special file called appspec.yaml. This is a YAML file that includes the instructions needed to deploy your application to your instances. And in this case, what you do is I've specified that this is for the Windows operating system. You can alternately specify Linux. And then what I'm telling it is, where it's going to pull the application's files from. In this case, I'm going to have a subdirectory in that zip file that's called app. And the destination where it will extract all the files in that app folder to is going to be a new folder on the machine called app server. And then what I'll do is I'm actually hooking lifecycle events in the deployment process. So I've got a before install where I'm going to install the .NET runtime. I've got application stop. This is the script that gets called if you ever remove the application in preparation to install a new revision onto the machine. After install, which really means after it copies the files, I'm going to have it register a Windows service on the machine because after all, I want my application to run when the machine boots. And then I'm hooking the application start event, and what I'm doing here is I'm actually starting the Windows service. And then finally, there's a lifecycle event called validate service. This is a really important lifecycle hook because this is what allows you to cause the deployment to fail if your test doesn't pass. So it's a safety check for you to ensure that your application is actually properly up and running and not giving you a false positive on the install. So let's take a look at what these scripts look like. So you'll notice they're all PS1 scripts. For Windows machines, you can either use batch files or PowerShell scripts. And if we actually look at the scripts themselves, in order, we'll look at install.NET. So this is simply a PowerShell script that will download the latest version of the .NET runtime from Microsoft. At the time of recording this video, that's 3.1.6. I'm checking to see if I've got that version installed on the local machine. If it isn't already installed, then I will download it from Microsoft's website, and then I will invoke the installer, and I'm just telling the start process commandlet to wait for the complete installation of it before it does anything else. Once it verifies that the ASP.NET runtime is installed in the box, then to actually install the application, let's go ahead and move on to after install. We'll take a look at application stop in just a moment. So The after install script, which is register service, this simply creates a new Windows service. I give it a name, ASP.NET Core Demo. That should be pretty familiar to you by now. I'm telling it where it'll find the binary that my service is using. And since this is ASP.NET Core, I'm going to specify the URL that the service is actually going to run on. And you may recall that I'm using a special NuGet package that allows me to run my application as a service. I've actually written my application so that when I see the -- service command line switch, it knows to start as a Windows service. Once I've actually got the service registered on the machine, then I just go ahead and ensure that port 80 on the machine is open so that external applications can reach the web application. Next, I'll go to application start, which is start service. Very simple command, PowerShell commandlet. All it's doing is just invoking start service on the newly registered ASP.NET Core Demo service. And then finally, I've got my validate service. And all I'm doing here is I'm calling smoke test. And this smoke test script simply just invokes a web request on port 80. All I'm doing is just verifying that I'm actually responding to traffic. In practice, what you're probably going to want to do is perhaps invoke a synthetic transaction or something that exercises a lot more of your application to verify that it really properly got installed on the machine. Now, the last thing I wanted to point out was the application stop hook. We kind of blew past that here. And the reason for that is that this actually gets invoked when it comes time to remove the application from the application server. And here's a really important distinction. The application stop event is always called on the previous revision. So I'm writing an application stop here where I'm removing the service. What this will actually do is it knows how to remove the current revision of the application. So what you don't want to do is write a stop service that knows how to clean up the prior version. You're always delivering the necessary script to remove the current revision. So always keep that in mind. If you have more than one revision deployed to an EC2 instance, the stop service is always going to get called on the previous package, not the package that's currently being installed. Okay, great. So I've got my AppSpec, I've got my scripts. Now what I want to do is actually create the zip file, which is my application revision. And to help with that, I've actually created a PowerShell script called create deployment. Let's go ahead and walk through the steps of what's actually happening. This will be exactly what you do inside your own CI/CD pipeline. So first, I'm calling .NET publish, and I'm just telling it that I want to use the release configuration. Next, I'm creating a working folder that will hold the contents of my application revision, because remember, we're going to zip this all up together. So I created a new folder. It's called deployment. And then I'll CD into that deployment folder. I will copy the contents of this CodeDeploy folder, the one that has my AppSpec and my scripts for the lifecycle hooks, into the root level of this deployment folder. Next, I'll ensure that I have my app folder, because after all, remember, my AppSpec, I'm telling it that I want to copy the contents of my application from an app subfolder. Then I'm copying everything that got built into the publish folder into that new app subfolder. And then finally, I'm just ensuring that if I had a previous version of the zip file, I want to blow it away because I want to make sure it's a clean file. And then I'm using the compress archive commandlet to actually zip everything together. All right, so let's go ahead and execute this script. So we'll call create deployment.ps1. And what this is doing now is generating a build of my application. And then it is zipping everything up into a new zip file. And once the archival process is complete, we'll just crank this open inside Explorer just so we can take a look at what the contents of this file looks like. So we'll look at deployment.zip. And as you can see, I've got that appspec.yaml. It's at the root of the folder of the zip file, because remember, CodeDeploy must see this file at the very base of your zip file. I've got the scripts that includes all the lifecycle hooks that I'm using to actually register the application and to smoke test it. And then finally, I've got the contents of my publish folder to just deliver the actual binaries of the application. Okay, so now it's time for us to actually deliver this to CodeDeploy. All right, so let's actually deliver this application revision to our CodeDeploy application. Now, CodeDeploy expects the application revision to come from an S3 bucket. So let's go ahead and create an S3 bucket that'll host the revisions we're going to deliver. So we'll navigate to S3, and we'll click on Create Bucket. And we are going to go ahead and create a bucket for the application revisions. And we'll click Next. And that's all we're going to really need to set. We don't need to set public access or anything like that. So we'll go ahead and click Next and create bucket. And now we have a place to actually host our application revisions. So let's navigate to our ASP.NET Core Demo bucket, and we're going to upload our deployment file. So I'm going to navigate to the folder that's actually got my, there we go, ASP.NET Core Deployment Samples, deployment.zip. And I'll go ahead and click on the upload button. And in just a moment, my revision will be ready to deploy to CodeDeploy. Okay, great. So let's go ahead and click on Services, and we'll navigate to CodeDeploy. And we'll go ahead and find our application, so ASP.NET Core Demo. And we'll click on the Deployments tab. And now it's time to create our very first deployment to this application. So we'll go ahead and click on Create Deployment. And it's going to ask us what deployment group we want to use. We'll use our ASP.NET Core Demo. Next, it's going to ask us what revision we want to deploy our application to. In this case, we have no previous revisions, so we'll go ahead and give it the path to the revision we just created. All right, so we'll paste this here. And next, it's going to ask for a deployment description, and we'll go ahead and call this first deployment. And then it's going to ask us if we want to specify any additional behavior settings. We're going to go ahead and leave it as a default here, and we're going to click Create Deployment. So we've got our deployment, and now what it's doing is it's actually deploying the application to some new EC2 instances that it's going to create. Let's go ahead and refresh here for a moment. And so you'll see here, now there are two EC2 instances. These are not the EC2 instances our auto-scaling group originally created. Let's go take a quick look at what that looks like. I'm going to duplicate this tab. And we'll navigate to the EC2 service. And if we look at our instance list, we now see there are a couple of new EC2 instances that are being launched. And the reason this is happening is because under the covers, what CodeDeploy Blue-Green did was take our initial auto-scaling group, and it effectively cloned it. So if you look here, we now have a new auto-scaling group. It's called CodeDeploy _ and then the name followed by the deployment ID. And so what's going to happen is CodeDeploy is going to wait for the instances to come up and running. The CodeDeploy agent got installed by our launch configuration, if you recall. And once the instance is up and running and the CodeDeploy agent picks up the new revision, it will then install that revision onto these instances. Okay, so what I'll do now is go to view the events on one of these EC2 instances, and it's going to take a little while for the EC2 instances to launch. So rather than make you sit and wait for the deployment process to complete, I'm going to use the magic of video editing, and I'll see you on the other side. All right, so our EC2 instances have been created, and now we're starting to reroute our traffic. And let's actually take a quick look at the status of the deployment inside the console. So as you can see, what's already happened is it's provisioned our EC2 instances. It finished creating them and installing the CodeDeploy agent on them through the user data. And it has already installed the application on these new EC2 instances. And right now, what's actually happening is it's in the process of repointing the load balancer from the EC2 instances that were in that original auto-scaling group to the ones that were just created. Now, this is going to take a couple more minutes here, so I'm going to go ahead and fast forward through that as well. All right, so it is finished reconfiguring our load balancer so that it's pointing in our new EC2 instances. Let's go ahead and take a look at what our application looks like on our new boxes. So if we go to our load balancers, and we'll click on the ASP.NET Core Demo, and we'll copy that DNS name, and we'll open up a new browser tab to navigate to the application. And there you go. Our application is now being served from the new EC2 instances that were created by our blue-green deployment. All right, so let's review what we went over in this video. First, we took a look at how CodeDeploy works and how you can use it to automatically install your applications on EC2 or even on-premises machines. As part of this, you can write scripts that are run as part of your CodeDeploy deployment, and not only can they help configure the machines, they can also do things like register daemons or services if you want to have your applications running whenever the machine is running. You also have the ability to have a validation step that will confirm that your application is actually working properly before you will allow the deployment to indicate whether it succeeded or failed. And by virtue of using that, you can actually set up what are called blue-green deployments, where it will fully install your application on new EC2 instances. It will validate that the service is actually running on the instance, and only after it successfully indicates that it was working properly, it will then start sending traffic to the new instances, and it can even decommission the old instances for you. Last thing I just wanted to point out was that a lot of AWS's CI/CD services, such as Code Pipeline, natively support CodeDeploy. And what this allows you to do is build a deployment pipeline where not only will you have your code downloaded and built using services like Code Commit and Code Build, but you can even have a code pipeline automatically deliver the build artifacts to your CodeDeploy applications for deployment on your EC2 instances. Thanks for watching. I hope this video was useful to you, and we cannot wait to see what you build on AWS.